Today we are going to discuss how to insert and delete values into a tree. Let us say we have to insert a value 10 and it goes here, and next let's say we have to insert value 6, and since it's a binary size tree, so 6 is less than 10, so it will be attached on the left side of this 10 root node. So we inserted value 6 and it got attached on the left side because it is less than 10. So if a value is less than the root, it will go to the left, and if it is greater than, it will go to the right. Now 14 is greater than 10, we compare it with 10, it's greater, so we will attach it on the right side. So similarly we go on and we insert 5, we compare 5 with 10, it is less than 10, we go to the left, and again we compare 5 with 6, it is again less than 6, so the left so we attach it on the left side of this node, 6 node. And now we insert 8, we compare 8 with 10, less than 10, so we go to the left. Now we compare 8 with 6, greater than 6, so we attach it on the right side of the 6. And now we insert 11, 11 is greater than 10, go to the right, and 11 is less than 14, so go to the left. And finally 18, 18 is greater than 10, go to the right, greater than 14, go to the right. So this is how a binary size tree is developed. And now we see how to write the code for binary size tree. And for writing the code, we have created a class tree, the tree class, class tree, and a node class. The node class has data members data and 2 pointers, left pointer and right pointer. When a node is created, both left pointer and right pointer are set to the null pointer, so in the start they are null, and when some node is attached on the left or right side, we assign the address of that node to these pointers. And then there is a tree class. The tree class has a data member with name root. Basically root is a starting point to start a tree, so whenever we need to traverse a tree, we start with the root value. And now we created an object of this tree class, and then we will define functions in this tree class, and there is a function of insert, and let's go to that function. So when we come to this function, we get the value and we see whether the tree is empty or not, and if the tree is empty, it means the root pointer is null, because root pointer points to the root value and it is null, so it means tree is empty. So we create a new node and assign that value to the node of its to that node, and now root becomes that node. So if the tree is empty, the newly created node becomes root. Otherwise, we call this function insert. It function has two parameters, data and root pointer. So data is actually which comes from the main function, and root pointer is used to traverse the whole tree and to find the suitable location for that node. So let us say we want to add a new node with value 17, and let's see what happens. So since node root is tree is no more empty, so we will call this function with two parameters, insert, and let's go to that function. And here we compare the value 17 with the root node, and root node has value 10, and see if 17 is greater than 10 or less than 10. If 17 is less than 10, this block of code will be executed, and we will go to the left, and 17 is not less than 10, so this block of code will not be executed either. This block of code will be executed because 17 is greater than 10. So 17 is greater than the root value, and we will go to the right. And here in the right we will see if the right side is null or not. If it is null, then we will attach it there, and if the value is equal, then we will display that duplicates are not allowed. Say if you try to add a value which is already available in the tree, we will no more add that value. And now 17 is greater than 10, so we will come to next node, and we will again call this function, and now the next node becomes the root. Now we start with 14 and compare 17 with 14, and yeah, as you know, 17 is still greater than 14, so we again come to the next block, and next we again call this function with value 18, and now when we compare 18 with 17, this time you will see that 17 is less than 18. So the first block of if else statement will be executed because 17 is less than 18, and so we will next what we will see if the left side of the 18 is null. Definitely it is null, so we will attach that node at the left side. So what we will do, we will create a new node and assign the value data 17 to the data member of that node, and the left pointer of the 18 value node becomes the 17 value node. So this is how we insert a new node in a tree. This code has been will be pasted in the comment area of the video. You can use that code from there, and this is it, how to insert a value into a binary search tree. Now we see how to display a tree. We can, as you have already seen in previous videos, a tree can be displayed in three ways: in order display, post order display, and pre-order display. In an in order display, we first go to the left side recursively, then we display the root value, and then we display the right side, go to the right side recursively. And in post order, the order is left, right, and root, and in pre-order the order is root, left, and right. So these are very simple recursive functions to display. The in-order display is very important because when we use in-order display, the values are automatically displayed in an ascending order. And finally, when you want to delete all the tree, you can also use the technique of recursion for deleting all the nodes of a tree. And you can use any order, but the point to be noted is that root must be deleted at in the end, because if we delete the root in the start, we will no more be able to find the left branch and right branch. So first we delete left, then we delete right, and finally we delete the root. So this is how we use how we delete or destroy a binary search tree. Okay जी, रब रखा।